Hey guys, so I put the problems at the top, 22, 23, 29, 30, 33, for the review sheet, and I got the answers there, so I don't have to take the time to scroll down to check to see if I'm right. So function f is twice differentiable such that f prime of x is less than 0, so the derivative or the slope is always negative, so always decreasing. Negative slope is how I interpret that. And f double prime of x is always less than 0, which means the concavity is always negative, which means it's concave down, right? But it's always decreasing, so it's only really that section of it that's concave down and always decreasing. If f of 1 equals negative 10 and f of 2 equals negative 15. So 1 is at negative 10, 2 is at negative 15. What could be the value of f of 3? Okay, so if it's concave down, that needs to continue to get steeper. So when this went over 1 and down 5, this needs to go over 1 and down at least more than 5. So it has to be at least negative 20 or lower. Well, actually lower than negative 20, because otherwise if it was negative 20 exactly, it would be very straight. So the only option, so lower than negative 20, I should have said. Because again, if it was exactly negative 20, then it would be linear, and that's not concave. There's no curvature there at all. There's no concavity. Or the concavity would be 0. So it's got to get even lower. And the only thing lower than negative 20 is option A, which is negative 25. On 23, it says the graph of f of x equals 8x to the 5th minus 5x to the 4th will have how many points of inflection? So we're talking second derivative, which is not bad because just a power rule and another power rule. Whoa, 160x cubed minus 60x squared. So when we factor this out, we can factor out a 20. And 30 doesn't go in, so 20x squared is going to leave me with 8x minus 3. 160x cubed minus 60x squared. Okay, so x equals 0 is a point worth checking, and positive 3/8. Now 0 is a double root, so I feel like it's going to be the same on either side. But anyway, if you plug in a negative 1, you're going to get a positive times a negative, which is a negative. If you plug in 2/8, you're going to get a positive 2/8 is going to give you 2 minus 3, which is a negative. So I was right, a negative again, so that stayed the same. No surprise, because that was a double root of sorts. And then anything bigger than 3/8, like a 1, is going to give you a positive and a positive, which is a positive. So the only point of inflection, there's 2 criticals, but only one of those points, critical points, is actually a point of inflection because of the change in concavity from concave down to concave up. So option 23, or problem 23, how many points of inflection? Just one. Just one. So don't misinterpret how many criticals versus how many points of inflection. So choice 1 was option A. 29. for what value of k will f of x equals x over x squared plus k have a relative maximum at x equals okay. So k is a constant. So we want to find the first derivative's critical points. So, and then check to see if it's a relative max or not. So bottom times derivative of the top minus top times derivative of the bottom is 2x plus nothing because the derivative of a constant is 0. All over bottom squared. X squared plus k minus 2x squared. So 1x squared minus 2x squared is, I'm going to go down here, is k minus x squared over x squared plus k squared. So the critical points, if k minus x squared equals 0, solving for x would be plus or minus root k, so those would be critical points. And then if x squared plus k equaled 0, you'd have to subtract k on both sides. X squared equals negative k, which you can't do, assuming k is positive. Did it say anything about that? No, but if k was negative, then this one would be undefined, and this one would be the same answers as those were. They're essentially the same thing, x squared equals k or x squared equals negative k. So one of them you're not going to be able to do, and one of them you will be. So here are options. So if k, and I think here we should do, they're looking for a relative maximum at 0.5. So the relative maximum is either going to be here or here. So if one of these equaled 0.5, it would have to be this one if we assume k is positive. So if root k equaled 0.5 and you squared both sides, k would have to equal 0.25. Yeah, so either this is your relative maximum or this is your relative maximum. And they were telling us that that had to happen at 0.5. So this value equals 0.5 or this value equals 0.5. In either case, you're going to get k equals to 0.25, and that's option E. That came together a little bit faster than I was expecting. On 30, two more. Next picture. Okay, so for similar, for what value of k will this function have a minimum at x equals 2? So again, first derivative, relative minimum. F prime of x equals, I'm going to rewrite this as x squared plus kx to the negative 1. So 2x minus kx to the negative 2 equals 2x minus k over x squared. And if I get a common denominator, the critical points are going to be at 0. But also if 2x cubed minus k were ever to equal 0, cubed root. So the cubed root of k over 2, wherever that could be. So if they're telling us that the relative minimum is at 2, then that critical point must be 2. So if I set the cubed root of k over 2 equal to 2, cube both sides, multiply by 2 on both sides, it would have to be a k value of 16, which is option A, which is correct. Okay, and 33, just for the record, and maybe I'm just not remembering, but I just like literally don't remember doing any problem like that. Of course, it's been 2 years because I was on maternity leave last year. I just don't remember doing this way, but perhaps there's another way of doing it, but this is what's making sense to me in the moment, so that's the way I'm going to teach it. And maybe I'm wrong. Maybe I always did do it this way. I just don't remember because it was 2 years ago. 33. For a given function f, which of the following statements is true? Okay, I'm going to... Which statement is true? Which means 4 of these are false. One of them is true. Okay, if f prime of a is not defined, if the slope is not defined, then a is not in the domain of function f. That's not true. So something could not be defined. Like, think of something like this. If that moment has a slope that's not defined, yet that value is still in the domain of the function. So 33, A is true, or is false. B says if the second derivative is positive, which means it's concave up, then the graph of the function is concaved downwards at A. Oh, that's definitely false. The second derivative at A is positive, so it has to be concave up, so that's definitely false. C says if the first derivative is 0 and the second derivative is positive, so concave up at A, so concave up, yet the derivative is 0 there because it does have a 0 slope, then the function has a relative maximum. No, that's a lie. That's a relative minimum. D says if the first derivative is 0, then the function has a relative extrema at A. Not necessarily, right? We've looked at ones like this, where we've got location A, slope of 0, but it's not a relative extrema, so that's false. So E better be the one that's true. If the derivative is 0 and the second derivative is positive, which means it's concave up and the derivative is 0, so right there at A, then f of A is a relative minimum, and that's it, of course. So was that right? All right, so hopefully that helped, and we're going to get to kind of general calc review over the next few days.